Problem 3 on the homework gave us a problem about a population. So n is the variable that represents our population. We're told at time 0 that population is 1,000. Similarly, we're also given information about birth rates and death rates. Our birth rate is given by a formula 40 plus 6t plus 6t squared, and the death rate is given by 50 plus 8t minus 3t squared. And so it's important to remember that these rates give how fast births and deaths are happening, but they don't actually give the number of births and deaths. So in order to calculate the number of births, we need to do a definite integral of the birth rate. So the births during year 1 correspond to an interval 0 to 1 is going to be computed as an integral from 0 to 1 of the birth rate, 40 plus 6t plus 6t squared. dt. Now, if you're curious about how this relates to our other examples of integration, the formula represents the rate, dt represents a short interval of time, and so a rate times a time gives a number. Now, in order to calculate this definite integral, we actually want to use the fundamental theorem of calculus because we know an antiderivative, and so we'll evaluate it at 1 and evaluate it at 0 and subtract, and we'll get the number of births. So when I evaluate it at 1, I get 40 plus 3 plus 2. When I evaluate it at 0, all those t terms go away. And so we're left with 45 births. Similarly, for the intervals 0 to 2 and, the second year is interval 1 to 2, and third year is the interval 2 to 3. So during the second year, the number of births is given by an integral of the birth rate, starting at time 1 to time 2, so that's our interval 1 to 2, that's our second year. When we integrate the birth rate, remember that's the formula up above, we have the same antiderivative, so the fundamental theorem of calculus says we'll evaluate our antiderivative at 2 and at 1, find the difference. So here's the here's the antiderivative at 2. We already found the antiderivative at 1, that's 45, and so the number of births during the second year is 63. So to calculate the number of births in our third year, we use the interval from 2 to 3. We integrate our birth rate times the time. Rate times time gives the number. The fundamental theorem of calculus turns that definite integral, which is the limit of a Riemann sum, into evaluating the antiderivative at 3 and at 2 and finding the difference. Plugging in 3, I get 120 plus 27 plus 54. Evaluating it at 2, which is what we did the last step, we had a value of 108. Find the difference, 93. There were 93 births during the third year. So here's a summary of the birth information that we found about the first 3 years. Now let's look at the deaths. Since we were told the birth rate, we can find the number of deaths by doing an integral of the death rate times the time. So death rate d of t, the function, dt gives a number per small interval, and we're going to integrate from 0 to 1 because that's our first year. The fundamental theorem of calculus says let's take our original function, find an antiderivative, 50t plus 4t squared minus t cubed. We'll evaluate it at 1, evaluate it at 0, and the difference will be the number of deaths during the year. So the number of deaths are 50 plus 4 minus 1 minus 0 from the evaluation at 0, and I simply get 53 deaths during the first year. Now to find the number of deaths in the second year, we want to integrate the death rate from 1 to 2, start at 1 and at 2 of the death rate, use the fundamental theorem of calculus use an antiderivative, evaluate it at 2, evaluate it at 1, and that will give us our value. So when we evaluate it at 2, we get 100 plus 16 minus 8. Evaluate it at 1, which was 53, and we get our value of 55. We do the same thing for the third year. Evaluate the antiderivative at 3, get 150 plus 36 minus 27, and we'll subtract the value that we found last time at 2, which was 108, which gives us a total value of 51. 51 deaths during the third year. Knowing the number of births and deaths each year allows us to calculate the population. So we're told that we start at 1,000. And so during the first year, we start with 1,000, but there have been 45 births and 53 deaths. So 8 more individuals have died than were born, and we have 992 individuals at the end of the first year. After 2 years, we start at the beginning of the year with 992. There were 63 births, 55 deaths, which corresponds to a net increase of 8. We're back to 1,000. And after 3 years, well, the start of that third year, we were back at 1,000. There were 93 births, 51 deaths. So we have a net increase of 42. So our population at the end of 3 years is 1,042. Finally, we want to find a formula for the population as a function of time. So what do we know? Well, we know the birth rate and death rate. And combined, those give me my rate of change. The rate of change of the population is given by the birth rate minus the death rate. So if I know the birth rate and the death rate, I can calculate the derivative. So let's use our formulas. And so when we write down those formulas for birth rate and death rate and simplify, we get that our rate of change is negative 10 minus 2t plus 3t squared. And so my actual population is an antiderivative of that. Negative 10t minus t squared plus t cubed, except we don't know which one, so there's an unknown constant of integration. Now, we happen to know the population at time 0, and so if I plug in 0 into all the terms for t, all that I'm left with is c, and yet that has to equal 1,000. And so now I know the formula for my population. So now if I check my work, if I evaluate n of 0, I get 1,000. If I get n of 1, what do I get? I get negative 10 minus 1 plus 1 plus 1,000. So that is actually 990. That's not quite right. So let's see if we can find out what went wrong. Let's double check. So 40 minus 50 is negative 10. 60 minus 8t is negative 2t. 6t squared minus, that's my mistake. negative, negative. So remember, that's a common mistake. So let's go back and fix that. We should have had, instead of plus 3t squared, we should have been plus 9t squared. Okay. 9t squared. That's going to change our antiderivative as well. So let's see about fixing that. I accidentally erased part of that. Okay, so let's fix that. So we have minus t squared still plus 3t cubed. And we'll still have the same integration constant. Okay, so let's see what changed in our formula. Let's see, that's going to actually change to a 3. And so this is now negative 11 plus 3 minus 8. Aha. We found it. Hooray! Okay. If I evaluate n of 2 using the corrected formula, I get negative 20 minus 4 plus 3 times 8 plus 24. So, those all cancel. Plus 1,000 equals 1,000. Hooray! And n of 3, negative 30 minus t squared is minus 9, plus 3 times 27 is plus 81, and so we are at 1,042. Yay! 3 times we got it. And so the antiderivative actually predicted the population, and in fact the antiderivative automatically took into account of how much the population has in its births and deaths. And so we have an actual population function of time.